All right, today we're going to learn about Python, how to read and write a text file. So by the end of this video, you should know how to read and write text files. And there are a bunch of different techniques you can use to do this. I have some code snippets on the right-hand side here. This is basically all the stuff I'm going to go through today. This is based on a document I'm putting together. And I have a little bit about like file access modes and IO functions that we're going to go over and some path information. But let's just jump right into it because you probably want to just see how to do this. So I haven't written any scripts to prepare. I'm just going to kind of shoot from the hip here. But I have these snippets here. So we're going to give it a shot. I don't have any data files yet. So let's give it a try. All right. So let's zoom in here so you can see the terminal a little bit better. I'm going to maximize this. Let's see here. So we want to open a file to start. We're going to call it my-file1.txt. So echo in some data into my-file1.txt, and we're just going to echo in some garbage data into this file, right? So there's our file right there, right? So yeah, that's it, and that's all that's in there is just this little, just that. Let's put a little bit more data in there just so we have something to work with, right? So yeah, cat the file out. There's our file. Bunch of data in there. It's all the same data. So let's run a script to. I should probably open up another terminal, and for actually running this. And all right, so there we go. Another terminal in the same directory. And we're going to edit our script right here. So we're going to create a script called test1.py. vi test1.py. There we go. Not real creative with the naming, but anyways, let's see. So we're going to say, I'm just going to copy this whole snippet right in here instead of bothering to type it out. And there we go. So yeah, well, you'll notice there's 4 lines of code here. This first line opens the file. So this is pretty kind of self-explanatory unless you're not familiar with file handles. So use the call to open, and open will open a file, and the first argument is the file name. Now this could be like an absolute path, a relative path, or you could just put the file name. If you only put the file name, it's going to look in the current directory. If you want to look at another directory, you put a whole path in there. We'll talk about paths more at the end. Now this second parameter is the mode. So it's opening it in read mode. Now you can have read, write, execute. Not execute, sorry. You can have read, write. You know what, let's quick just run through the modes. Yeah, we should go over the modes real quick. So before we do anything. All right, so file access modes. You have R, R+, W, W+, A, A+, and X. So R is for reading. There's an error if the file doesn't exist. This is by default. So if we left this R out, it's going to use the read mode by default. Now R+ is reading and writing, gives you the ability to read and write with the same file handle, and there's an error if it doesn't exist. So if the file does not exist. Now W, and if you want to look all this info up, just check the link in the description. I'm going to have a link to a document. This is all part of a document I'm putting together, so I'm going to have a link to that in the description of the video. So anyways, W will open it for writing, and it will overwrite whatever's there. W+ is reading and writing, and it overwrites whatever's there and creates a new file if there's not a file there. So as just a regular W would also create a file too. All right, so A is for append, so it writes to the end of the file. So it won't overwrite what you already have there, it'll just add new data to the end. Now A+ allows you to append to the end, but it also allows you to read. And an X will just create the file, and there's an error if it already exists. So there you go. There's the different there's the different modes just to be aware of. I know we wanted to just kind of jump right into this, but I figured I should probably go over that since I came to the parameter anyway. Anyways, data. So notice that when we call open, we're assigning the return value of that to F. Now F is a file handle. You don't have to call it F, it's just a variable. You can call it my file handle or X or A or B or whatever you want to call it. So assign that to a variable, which is your file handle. So this assigns a file handle to f. Now, using the file handle, you can call the method read, and this will read the entire file right into your. It reads the entire file into a variable, and we assign it into the variable data. So we have all the contents of the file assigned to this variable, and then we have to remember to close it. So we on the file handle we call close, and that closes the file handle. You should always do that. And print. So if we want to actually see what that data is, we're just going to print it out. So technically, you could put this print inside here before closing it. That's fine. You can do all sorts of stuff before you close the file, but so long as you do remember to close it, and so long as logic doesn't prevent it from getting closed, you want to make sure it does get closed. So there's that. Now I'm going to open up the other. So I'm going to write this out. There we go. Save our changes. Now I'm going to open up this terminal, and now you see we have two files in here. We have our data file, that's a txt file, and we have our Python file, which is the one we have open in the editor here. So let's run this Python file, Python test1, and it's going to read that. See, there we go. It read the file, and it printed it out, and that's all it does. Super simple. So it reads in a text file and prints it. Super ridiculously easy. If we want to verify it, we can cat our text file and print it out, and yeah, that's what was in it. So let's say if we wanted to, let's change our text file just to do it. Now add some more data here. Say test blah 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 XYZ. Add some more things here. ABC. Just so it doesn't look like the same line over and over, right? So now we have a new text file, right? And let's just run this again, and boom, there we go. Printed out the contents of the new text file using our Python script. So to run our script, test1.py, just say Python and the name of your script, and that's it. That's all you have to do to run your script. So yeah, this file is it's the same thing we have above. So it's the same thing we have open in the editor here, and I'm probably going to use the same file for this whole thing. So anyways, let's open up this, let's see what we have next. So that's how to read a file, right? Now say if we want to write a file, let's copy this little snippet in here, and then we're going to talk about it a little bit. So paste, and I'm going to comment this whole thing out, just you know what, we don't even need this. I'm going to delete all of this and just leave this here. So there we go. Write this out. So there we go. Save the changes. Now here we're doing the same thing. We're calling open. We're passing the name of the file. But now the thing we're doing different is using a W for write. So this is going to open in write mode. And you assign this to a variable just like we did before. And then and that's our file handle. And on our file handle we call write. But this doesn't, instead of returning data like you do when we read, we're actually writing data out, so we specify the data that we want to write. So this is a test. We're going to write out the data called this is a test to that file. And then after we're done doing that, we're going to close it. So this script isn't going to give us any output, but it's going to overwrite that file that we had there. So clear this. And so we have this file called my file. So cat that out, my file. Remember we had all this garbage data in here, right? So we're going to overwrite this file with our script. So all we have to do is run our script here. The script doesn't give us any output because we're not printing anything, but now that we ran the script, and now it just overwrote this file for us. So if we cat this file out now, we'll see it's overwritten, and the only thing in it is this is a test. That's the only, and it actually doesn't even have a new line. So my terminal just returns right here on the same line. So it just wrote out the data, this is a test, and it didn't even put a new line character at the end. I'm going to show you how to add a new line character, even though that wasn't part of the tutorial. Let's see if this works with single quotes. So run the same thing. It overwrites the file. Now cat the file out, and there you go. There's a new line character. So if you want to write a new line character after writing to the file, you can do a /n, and that'll take care of that. So yank put. All right, now we're going to write two things. This is let's just go like this. Blah blah blah, And then let's take that new line character off of this one. And this is going to be 1, 2, 3, 4. Oops, 1, 2, 3, 4. There we go. Whoop. Yeah, I don't know how I managed that. That's a VI for you. All right, I'm gonna delete this line and try that again. All right. Yeah, that's the magic of VI. All right, so here what we're gonna do, save the changes and write this is a test and then a new line, and on a new line we're gonna say ASDF SDAF, and then we're gonna write again, but notice there's no new line after this, so both of these should probably go on the same line. So we're gonna have 2 lines. This is the only new line character. So let's give that a shot. Let's run our Python script and say cat my file. This is a test is 1 line. Then the next line has those 2 other writes all concatenated into 1 line because there's no new line character. So if you don't put this return character here, or this new line character rather, it's gonna you can write as many times before you close the file, and it's just gonna keep writing to the end of the file. And it's not going to write to a new line unless you tell it to do a new line. Anyway, say if we take this line and try to run it after the close. Let's try that. Yeah, and you know, I'm going to leave this open and run it in this. All right, so run Python test1.py, and now we have an we have an error, IO operation on a closed file. So if you try to write to a file or do any operations with your file handle after you've closed it, you're going to get an error. Okay, so that's all fine and great. Let's move on to the next example. I should probably try to move through these a little bit more quickly because I've already eaten up a pretty fair amount of time, and you probably just want the answers. Well, if you really want the answers fast and don't want to watch this video, click on the link in the description. You can just copy and paste these snippets and it'll give you a nice little explanation. You don't have to sit here and listen to me go blah, blah, blah about this for so long. Yeah, so if you want the fast way, just click on the link in the description and check my guide out. But if you want to watch this video, by all means, continue watching it. I'll probably have some neat little tips and stuff, or not, depending on where you are and how you learn best. Anyways, so that's writing a file. Now we're going to learn some easier syntax for reading a file. So delete all those lines, paste this new one in here. All right, so now this is some different syntax, and notice there's no close here. So what happens is, instead of saying open and assigning it to a file handle, you say with open, and you basically, open gets called the same way. We're gonna open a file to read it, right? And you say open my file, and then the mode you wanna open it in as file handle, right? As F is gonna be the file. In this case, F is still the file handle, but you say as, and then the file handle goes right here. And then a colon. Then on the next line, but indented, you have, so that's how the syntax works with this with statement. You indent it, and we're gonna, on the file handle, we say read and assign that to a variable. So basically you can use that file handle you can continue using it so long as it's indented. Once you leave this indented block, it's going to close automatically for you. So that's the nice part about this. You don't have to remember to close your file handle, and you don't have to have one extra line of code, making your code all messy. So that's nice, and it's a little bit, I would say slightly less straightforward, but no big deal. The syntax is, but it's nicer because you don't need 2 lines. You don't need an open and a close. Closes for you automatically. Just any file operations with your file handle, you do them in the indented block. And then since here we're saving all the data to a variable, we can use the data outside that block. But if you tried to do a read outside the block, it's going to give you an IO error. But printing that data is totally fine. Anyways, so let's give this a try. Remember that our file has the same stuff that it had before. But clear this, and all right, so cat my file. Yeah, my file has the same thing. This is a test, blah, blah, blah. All right, so let's run our script, and we are going to it's going to read the file and print it out the same as the first example. And there we go, it reads it and prints it out. So there you go. So what else do we want to? Yeah, that's pretty much it for that one. Let's move on to the next example. So easier syntax, we covered that. Now we're going to read lines as a list. So this one we're going to read from a file, and basically we're going to read in each line into a list. So a list in Python, a list is basically, it's an array. For other languages, you call it an array. Python, it's a list. That's just what they call arrays in Python. Anyways, so this will read every line in the file and store each line in it as a new element in an array. So this first line, same thing as we just did, with opens the file, and then but instead of reading the whole file into a variable, you're still reading the whole file, but instead of just reading it as one big string, you're going to read each line. And so instead of this being a string, this is actually going to be it's going to be an array or a list. And then we loop over the list and print it out like that. So let's give this a shot. Now we only have two lines in the file, but let's try this anyway. All right, so run that, and there we go. Well, yeah. So anyway, I guess that counts as 3 lines. Why does that count as 3 lines? You know why this one has a carriage return in it, or not a carriage return, but a new line character. But anyways, let's see here. Yeah. So anyways, I put those each into. Let's run this like this, and there you go. Okay, so it's just putting a space between these, but basically this is and I'm pretty sure that new line character brings it. Yeah, because anyways, it's just giving us a new line in between, but that's not a separate element. That's the same. It's still just 2 elements for 2 lines in the file. So that makes complete sense. So the next thing we're going to do is print out this array. So print A. So we're just going to see what the representation of this list looks like. So same thing, but there we go. So it prints out the stuff we printed there with the for loop, and then you see an array. The array has an element for each line in the file, has this first line, and then this second line. And the first one has a carriage return in there. Or I don't know why I keep saying carriage return. It's a new line symbol. Anyways, carriage return would be like a /r. A new line would be like a /n. Just to clarify that. I don't know why I keep saying carriage return. Anyways, so that's that. That's how you would read lines into an array. So that's a nice example and all. Let's move on to the next one. All right. So next example is. Let's open up Kate here, and so reading a large file. So why did I put my pad? Did I copy and paste over something? All right, so read lines as a list. I think I might have. So this is the document I'm throwing together. I think I might have. I copied and pasted reading large files. All right, I'm going to grab this. This is not published to the internet. I just use Google Docs for this. But anyways, jump back up here. Looks like I somehow pasted over this. Anyways, restore that. Yeah, so reading large files is done like this. And I pasted this section on paths down here. I don't know how I managed to do that. Anyways, grab this, paste it in here. Now what this does is it lets you read large files. And all right, so here's the actual example that we want to use. This is the actual snippet we want to use for this example. So the idea is that, say if you have a large file, you don't want to slurp the whole thing into memory and just have one gigantic file in memory. Like say if your file is many gigs large and you only have so much memory on the system. Like say if you have a 100 gig file and you only have 16 gigs of RAM, you're not going to be able to fit that whole thing in memory. And even if you could, you're just wasting so much memory and it's so inefficient. So that's not a good thing. Generally, you want to be able to, so like in this case, what you do is you would open the file like you normally would, and then you would read line. Now this just reads one line from the file, and it pulls that line into a variable. Then you can do something with that variable, like print out that line. And then we're going to loop over that data. So we're just checking if we use this while loop, and we say while data, we're saying while there's still data in the file, while that variable still had some data returned, we're going to continue doing that same thing, read a line and print some data and print out that data that we got. So it will read the file line at a time, and it only stores a line's worth of data in memory at any given time. So no big deal there. I put this here as a placeholder, because I commented out process data. Now the idea is you would probably with each line, you might do something with it, do a search and replace and then write it out to another file or send it across a network connection, whatever things you want to do to it. You're probably going to read a line, do something with that line, and then continue on and read the next line. So this is like a placeholder for what you would be doing. It would look like this, except I haven't actually defined a function like this. So we're going to leave that commented out just so we can run this. And yeah, so basically we would run, so that's pretty much it. And you would probably put that process data line, right? If you did have this defined, you'd probably put it here too, right? So your first line that you read, you do it before the while loop, and the only reason I'm doing that is so that I can test that it's still being read. There are probably other ways to do the same thing too. But anyways, the point is you're using the read line function to only read one line at a time instead of pulling the whole thing into memory like we did with our other examples. So this is the actual example to use, and I'm going to make sure to put this. This is actually better than what I did here. This is like a terrible example here. All right, so yeah, trying that out. I'm still putting this document together, but trying that out, it looks like this was the better choice, and I'm just gonna compare those side by side. But yeah, and I don't want my syntax highlighting on that. All right. Anyway, yeah. So that's me editing my document. That's the document you're gonna see. It's gonna be formatted completely differently, and all cleaned up and everything. But that's the document you're gonna see published. When I publish this video, I'm gonna have that document already published onto my website, which you'll find in the link in the description. So, anyways, moving along here. Yeah, so let's, I'm gonna leave this open and just delete all that, and let's see what we have next. So reading large files, not gonna look like this snippet. It's gonna look like the snippet I just showed you. And now you can use a raw string to avoid special characters. Oh yeah, all right. So it looks like this was the same code from there. All right, that was my copy and paste error. All right. Anyway, so write a list to a file. If you want to write a list out to a file, that's what the write lines function does. So this one's pretty simple. This is kind of the equivalent of well, we'll just take a look at it. So all this does, you open a file in write mode, and you use write lines, and you specify an array, and it will write every element in this array out to the file specified. So say if you have a equals, maybe you want to say a, I'm not being super creative here, b, c1, yeah, all right, that's good enough. I'm not gonna, whatever. Anyway, so you have an array. Write this out, and let's try running this. All right, so this is going to, so Python test1, run that test, and now let's look at our data file, cat my file, and there we go. It wrote out ABC1. So it took each of these, took each of these and wrote it as a line into our file, and it didn't use new lines, which is I guess the idea is that these would actually be entire lines that would, I guess that's how it behaves. That kind of seems counterintuitive to me, but apparently that's how this function works, so that's how you should expect it to work in your code. So try this again, cat the file, and there you go. There's a new line for each element. So I guess that's assuming each of these was a line. It'll write them all out, but it expects the new lines to be in there already. So I guess its idea of what a line is already has the new line in it, like this. So that's fine. All right. And you could also say f dot write, and you could say a. Now let's see how this behaves. If you just write, yeah, so expected a string or other character. All right, yeah, that's fine. So you can't just, it needs a string. You can't just write an array out. You could print an array, but you can't just write it to a file. So let's say if we convert this to a string, which we should be able to write out, cat the file, and there we go. So we converted our array to a string, and after writing each line, we then wrote the entire string representation of our array out to the file as a single line. So anyway, that's that. You know, do what you want with that example. Now we're going to cover writing a large amount of data. So hopefully the way I cobbled this example together is good. You know, I haven't run any of these snippets yet. This is the first time I'm even running these. I just typed these up real quick in a Google Doc, and you know, this is me testing them for the first time. I mean, I've used them before, but you know, I very well may have typos and stuff. So anyways, with open this file. So, you know, you're just opening in write mode. Now this is assuming there's like a large amount of data, like maybe it's not just a bunch of stuff stored in this tiny little variable in memory. Like you might be pulling in a bunch of data from, maybe it's getting generated or downloaded from the internet, and as the data is coming in, the idea is like as it's coming in, you're going to write it out to a file. So I guess the idea is you open the file, and while more data is coming in, so I don't have a source for data, so I'm not even going to run this example, unfortunately. But I really should have come up with like something for that, like downloading or something. But anyways, the idea is while there's more data, you test that like more data is coming in from wherever your data source is. You'd say generate, and yeah, while more data, generate the data. So pull it in, and then write it to the file. Then check if there's more data, pull it in, write it to the file. So anyways, point is, this write is just going to write another line to the file, another line to the file, another line to the file. Kind of like before, how we were dealing with reading large files. We would just read a line at a time instead of read the whole file in. This just writes a line at a time instead of, you know, writing, instead of just writing the entire thing at once. So, I mean, that's the idea behind that anyways. So let's talk, we talked about file access modes already. Let's talk about these functions. I'm gonna paste these into here, even though these aren't a script. This is just a list of functions that I'd like to go over and that we should be aware of. So I'm just gonna paste it into VI because this is syntax highlighting and it's nice and neat. So these are actually comments, even though I haven't commented them out. I put the comments at this is gonna be a table. When I document this, I'm gonna actually put these in a nice little table on my web page. So you can expect this to look nice and neat and pretty when I'm done. But anyways, the stuff on the right is comments, and the stuff on the left is actual are the actual functions. So I'll make that a little bit bigger. Now we've talked about opening things. It just opens a file and creates a file handle. Writing, this will write a string to a file. Write lines will write an array or a list to the file. Read will read the entire file. Now if you say read 5, it reads the first 5 bytes. This just reads 5 bytes from the file. Now read line will read a line from the file. Read line 5 will read lines with a max of 5 bytes per line. So it'll read a line, but only 5 bytes. And then the next line 5 bytes, and so I've never used this or this before. I just haven't had a use case for it yet. Now read lines, entire file as a list. So we've already gone over that. It'll read the entire file as a list. Now seek, you could move to a different place in the file, and that just moves where you're writing to or reading from. This seek like this will move back to the beginning. So like, yeah, I have not actually used the seek function before, and close just closes the file, and which you won't need if you open it with a with as syntax, but that we covered. So that's that. I almost feel like I should show how read specifying a number, like the number of bytes. I should show how that works. Let's talk about paths. So paste this in here. So paths. So your paths might look like this depending on what OS you're using. Now, if the file is in your local directory, you can just specify the file name like what we did. Now, if you're running on Windows, your path might look like this. Notice your slashes go this way. You'll have a D drive or C drive or whatever drive you have on Windows. Now, if you're on Linux, your path is probably going to look more like this. Now, your file could be anywhere, but this is an example path. This is like the path to my home directory, and the file in my home directory. Actually, I have it. It's in a TST. In a test directory. I believe the path would actually look like test, like that. That's how my file is. Anyway, a note about special characters in your file name. Like if you have special characters, that could lead to issues. So like let's say if you had a Windows path, where the slashes go like this. So let's say you have a slash like this for your Windows path. That's going to be fine if you have like a /dir probably. But if you have like a /test, that would interpret the /t as a tab instead of a /test. And you could escape that. You could say escape like this anytime there's I believe you could do that, but you don't want to have to deal with that. Rarely you're going to have tabs inside your file names. I mean, you could, but it's a good practice. I'm not in the habit of this actually, but it's a good practice to use an R for a raw string. Using an R creates a raw string, so you don't have any of those escape characters. That's also a nice thing to use with regex. I am actually in the habit of using that with regexes at the moment. But anyways, that's that. I actually feel like we should use, I'm going to try to use one of these, I'm going to use this, and I'm going to say read, and I'm going to specify the number like what I was saying. So, all right, so paste this in here, and all right, so I'm going to, let's try this example first, and then, all right, let's just, what's in our file? Let's say cat my file. My file has a few things in it, so yeah, for this to even make sense, let's create a new my file. So echo. All right, so let's say let's populate that with there we go. So now my file has a ton of data in it. Only thing is it's all on one. Yeah, that's not good. All right, so that's a bad way to generate some data for my file. And I'm not going to bother to do. Yeah, I don't want it concatenated all together like that. So anyway, whatever. I could probably just like loop over it or something, but I'm just going to generate some data. I'm just going to generate some. I'm just going to go like this, paste, put that in there. All right, there's some garbage data in there. My file, that's what my file looks like. The first line is really, really long, and the rest of the lines are shorter, but all the same thing. Now, let's say if we run our Python test.py, and all it does is print that data out. It just prints out what's in the file. But let's say if you limit this to 5, this is only going to read 5 bytes. So it only read the first 5 bytes and it stopped. So it didn't even read these other lines. It just read 5 bytes and stopped. So well, let's take a look down here. So we had read and read lines. Read a line at a time. All right, so read line. Yeah, because if you say read, it's just gonna, it's like if you run read twice, it's just gonna read the entire file into that same variable. So it's gonna give you the same results, right? Or not. Okay, so calling read multiple times is, it tries to read the whole, it would read this whole file into this, but it only reads the first 5 bytes, then the next 5 bytes into that same variable, I believe is what it's trying to do. So, yeah, so reads 5 and then it reads another 5 into that same variable, which is kind of interesting. So let's say if we told it to read line, like what we have here. So read line at a time. So these are both from the same line. If you look here, if you look at our output from from running this is oh yeah, and it did add user. Yeah, so it overwrote it. It took so it did take 5. Yeah, that is exactly what it should do. So it overwrote the yeah. So this is a space. So this is ACPI space, then this is ADD-US. So yeah, it read the first 5 bytes, stored it in this variable, read the next 5 bytes, and overrode it into this variable. That's what's going on there. So if we change this to read line, it's still going to overwrite it. Anyway, that's fine. It does the exact same thing. It achieves the same result because we're just limiting it to 5. What else should we cover? So we got, the entire file or just a line. I guess it doesn't matter. Like if your size is smaller than the entire, if it's smaller than the line, it's going to read. It's not going to read the whole file. It's going to be the same result whether you're trying to read the whole file or the line. But anyways, either of those functions allow you to use a 5, so you can limit the number of bytes read, which you could have use cases for that. But anyways, I almost want to say seek. Let's try to seek this file handle ahead a little bit, just for fun. Let's say seek 25. Now so I guess we're jumping ahead. So let's run this, and there we go. It jumped ahead 25 probably bytes. So we can move the file pointer ahead by 25 before we read anything. Then we're going to read 5 bytes and then read another 5 bytes. So that's kind of interesting. So this is like bytes 30 through 35, I would guess. But that's how you use the seek function. I've never used that before, but that's kind of neat. You could do all sorts of neat things with files using the seek function, I guess. I probably should start incorporating that into scripts. But anyways, that's about all. I think I've been recording this for like 43 minutes now. So yeah, this is way too long just to show someone how to read and write files. So hopefully you found this useful. If you did, give me a thumbs up. If you have any questions, comments, criticisms, praise, anything you want to say, leave it down in the comments below. I want to know what you think. I'll try to answer your questions if I don't have too many, if I don't have too many people commenting. I try to respond to comments, and what else? If you want more content like this, subscribe to the channel, hit the little bell icon, and if you want, we do a lot of stuff like hardware, servers, electronics, Linux, systems administration, code, we've done a little bit of Python so far. We're going to be doing Lua, Perl, Java, JavaScript, and mostly practically anything I can come up with. I'm just going to try to cover as many different languages and as many different topics as I can. We're going to have a lot of like disassembling things, taking things apart, hardware related stuff, code related stuff, data related stuff, big data stuff, Hadoop, Docker, and a lot of other really interesting things. We're going to go over coding and automation and stuff, build robots with Raspberry Pis. So there's a lot of neat stuff we're going to be doing on this channel. And if that stuff sounds like the kind of thing you want to, that interests you, you might want to definitely make sure to hit that subscribe button and also hit the little bell icon so you get an icon. So you get an alert when I push out a new video, so you can keep up to date with all the excellent content I'm going to be pushing out. And as always, hopefully you found this video useful and enjoyed watching it. Thanks for watching, guys.